Imagine a weapon that travels at 2 miles per second. At that speed, the very air in front of the missile does not have time to move out of the way. The atmosphere compresses so violently that it heats up to thousands of degrees, wrapping the weapon in a blinding, superheated sheath of electrically charged plasma. It is moving so fast that it outruns its own acoustic signature. By the time the radar warning receivers on an enemy warship register the threat, by the time the sirens begin to wail in the Combat Information Center, the engagement is already over. The target is destroyed before the human brain has the physical capacity to process the sound of the approach. This is the terrifying, unforgiving physics of hypersonic warfare. For the better part of a decade, the strategic planners of the Western Alliance sat in darkened briefing rooms in Washington, London, and Canberra, and watched with growing anxiety as the authoritarian powers of the world seemingly mastered this domain. The Russian military proudly unveiled the Kh-47M2 Kinzhal and the Avangard glide vehicle. The Chinese People's Liberation Army Rocket Force deployed the DF-17, a hypersonic weapon explicitly designed to evade American missile defenses and sink aircraft carriers in the Western Pacific. The narrative took hold that the West was losing the arms race. We were told that American and Australian hypersonic programs were paralyzed by risk aversion. We were stuck in the research phase, treating these weapons as exquisite, fragile laboratory experiments that cost $100 million apiece and required years of pristine testing just to get off the launch pad. But early in 2026, the paradigm violently shifted. The intelligence agencies and the defense industrial base of the Anglosphere realized that the next global conflict will not be won by the nation with the best laboratory. It will be won by the nation with the most relentless, unstoppable assembly line. They realized that the research phase had to die. It was time for mass production. And to build this massive, futuristic arsenal of democracy, the United States did not look to the crowded factories of California or the backlog testing ranges of Nevada. They looked to the vast, resource-rich and heavily industrialized expanse of the Australian continent. Australia is no longer just a customer in the global arms market. It has become the hypersonic workshop of the free world. Welcome to Doctrine of War. Today we are executing a forensic deep dive analysis into the Industrial Revolution that is currently rewriting the balance of power in the Indo-Pacific. Here is the thesis for this episode. A silver bullet is useless if you only have one of them and the enemy brings a shotgun. The Western Alliance has fundamentally recognized that to deter the massive, industrialized war machine of the Chinese Communist Party, we cannot rely on a handful of expensive prototype missiles. We must be able to print them, assemble them, and launch them by the thousands. If you are beginning to understand why the true outcome of modern great power competition is not decided by diplomatic speeches, but by the brutal, unsentimental mathematics of high-tech heavy manufacturing and sovereign supply chains, hit that like button and subscribe to Doctrine of War. We strip away the political rhetoric to bring you the cold, kinetic realities of how the free world actually builds, fights, and wins. Your support is the engine that keeps this channel operating at the absolute tip of the spear. For years, the AUKUS agreement has been synonymous with nuclear-powered submarines. But beneath the surface of Pillar I lies the far more immediate, kinetic reality of AUKUS Pillar II. We are going to break down the 3D-printed Apex Predator, how a Queensland aerospace company is utilizing advanced additive manufacturing to print scramjet engines with zero moving parts. We are going to explore the SCI-FARE kill chain, how these revolutionary engines are being strapped to the wings of Royal Australian Air Force fighter jets to create an unstoppable strike package. We will analyze the brutal economics of swarm warfare, and why mass production is the only way to penetrate the air defense shields of the Chinese Navy. And finally, we will look at the hypersonic workshop, how Australia is leveraging its massive critical mineral wealth to create a sovereign titanium supply chain that Beijing cannot block. Let us begin by looking at the death of the laboratory, and why the West was forced to aggressively change its strategy. The testing bottleneck. To understand why the sudden, aggressive surge in Australian hypersonic manufacturing is so incredibly vital to the survival of the free world, you must first understand the catastrophic bureaucratic and logistical bottlenecks that were choking the United States military. For the past 15 years, the Pentagon has funneled billions of dollars into a multitude of competing hypersonic development programs. The Air Force had the AGM-183 AARW, Air-Launched Rapid Response Weapon. The Army had the Long-Range Hypersonic Weapon, LRHW. The Navy had the Conventional Prompt Strike, CPS, program. The science behind these weapons was sound, and the American aerospace engineering was, as always, unparalleled. But the programs continuously slammed into a massive, immovable brick wall: testing infrastructure. To develop a missile that flies at Mach 5 or faster, you cannot simply rely on digital computer simulations. The thermal dynamics of atmospheric friction at those speeds create a chaotic envelope of superheated plasma that can melt traditional aerospace materials in seconds, burn through internal wiring, and completely sever telemetric communications. You have to fly the physical hardware. You have to break it, find out why it broke, fix it, and fly it again. But the United States only possesses a handful of highly instrumented, secure testing corridors capable of tracking a projectile moving at 2 miles per second over hundreds of miles. Ranges like the White Sands Missile Range in New Mexico or the Pacific Missile Range facility off the coast of Hawaii are heavily overbooked. Scheduling a single hypersonic test flight could take upwards of 2 years. If a test failed because a simple telemetry fin malfunctioned, the entire program would be stalled for another 24 months waiting for the next available slot on the calendar. This is the exact opposite of the fail fast, learn fast methodology that drove the rapid aerospace innovations of the Cold War. The Chinese military, unburdened by strict environmental regulations, bureaucratic range scheduling and public oversight, was conducting dozens of hypersonic test flights every single year. The West was conducting 2 or 3. The Pentagon realized that if they did not solve this testing and development bottleneck immediately, they would be mathematically outgunned in the Pacific by the end of the decade. They needed a testing range that was massive, secure, and largely empty. And they needed an industrial partner who was willing to move with reckless, aggressive speed. The HyFliTE awakening and the Woomera solution. Enter the Australian continent, and the activation of the AUKUS Pillar II agreement. Australia possesses the ultimate geographic asset for aerospace development, the Woomera test range in South Australia. To comprehend the scale of Woomera, you have to discard traditional metrics of military bases. Woomera is not a base, it is a sovereign testing continent. Covering over 122,000 square kilometers, it is the largest land-based military weapons testing facility in the world. It is roughly the size of England. It is a vast, largely uninhabited expanse of desert, heavily instrumented with the most advanced radar, telemetry, and optical tracking systems on the planet. Most importantly, its airspace can be completely restricted, allowing for the secure, unobserved testing of highly classified hypersonic flight vehicles over massive operational distances. Recognizing this unparalleled asset, the United States, the United Kingdom, and Australia formalized the HyFliTE Agreement, Hypersonic Flight Test and Experimentation Project. This agreement fundamentally shifted the dynamic of the alliance. Australia ceased to be just a convenient piece of real estate where the Americans could test their toys. Under HyFliTE, the Australian Defence Industrial Base was fully integrated into the design, manufacture, and execution of the hypersonic arsenal. The agreement mandates a relentless, accelerated cadence of up to 6 massive trilateral hypersonic flight test campaigns. But the true strategic awakening was the realization that testing American missiles in Australia was only half the solution. If the West wanted to truly outpace the authoritarian regimes, they needed to build the missiles in Australia as well. The Western Alliance realized that consolidating all of their high-end hypersonic manufacturing within a few vulnerable facilities in the continental United States was a massive strategic risk. In a high-intensity conflict, supply chains break, factories are targeted by cyber attacks, and logistical shipping lanes are contested. To survive the coming storm, the free world required a distributed, redundant, and highly aggressive manufacturing base located firmly within the Indo-Pacific theater. Australia was elevated from a testing ground to the hypersonic workshop of the Alliance. And the centerpiece of this industrial revolution was quietly being forged in a laboratory in Queensland. The physics of the Scramjet. When the public hears the word hypersonic, they generally picture a massive, towering intercontinental ballistic missile (ICBM) launching vertically into space, and then releasing a glider that skips across the upper atmosphere. This is known as a hypersonic glide vehicle, HGV. China's DF-17 and Russia's Avangard operate on this principle. They are incredibly dangerous, but they are also astronomically expensive, massive in size, and require enormous, highly vulnerable launch infrastructure. Australia decided to master a completely different, vastly more tactical, and arguably much more complex form of hypersonic physics: the air-breathing scramjet. To understand the genius of the Australian approach, you must understand the brutal mechanics of a supersonic combustion ramjet, or scramjet. A traditional jet engine uses spinning fan blades to suck in air, compress it, mix it with fuel, and ignite it. A ramjet dispenses with the spinning blades and uses the sheer forward speed of the aircraft to compress the air, but the air must be slowed down to subsonic speeds inside the engine before ignition. A scramjet operates in a realm of physics that borders on magic. The air entering the engine is moving at supersonic speeds, thousands of miles per hour. The engine must inject fuel into this supersonic hurricane, mix it perfectly and ignite it, all while the air is racing through the combustion chamber in a fraction of a millisecond. Aerospace engineers often compare it to trying to keep a match lit in the middle of a Category 5 hurricane. If you can achieve this, the advantages are staggering. Because a scramjet breathes oxygen from the atmosphere, it does not need to carry massive, heavy tanks of liquid oxidizer like a traditional rocket. This makes the missile significantly lighter, smaller, and vastly more maneuverable. Enter Hypersonics Launch Systems, an aerospace engineering company based in Brisbane, Queensland. While massive defense primes in the United States were struggling with the immense complexities of scramjet thermal dynamics, this Australian firm achieved a monumental breakthrough. They developed the DART AE Additive Engineering Hypersonic Vehicle, powered by their proprietary Spartan scramjet engine. The DART AE is not a concept drawing, it is a physical, kinetic reality. It is a 3-meter-long drone-like vehicle designed to fly at an absolutely mind-bending speed of Mach 7, with evolutionary designs pushing toward Mach 12. But the true genius of the Spartan scramjet engine is not just its speed, it is its simplicity. The Spartan engine has absolutely zero moving parts. There are no spinning turbines to brake, no complex mechanical fuel pumps to jam, and no moving exhaust nozzles to melt under the extreme heat of hypersonic friction. The engine generates thrust entirely through its pure, highly optimized aerodynamic geometry and the physics of shockwave compression. The additive manufacturing revolution. How do you build an engine capable of surviving Mach 12 temperatures with zero moving parts? You cannot cast it in a traditional foundry. You cannot machine it out of a block of metal using standard lathes. The internal geometry required for supersonic fuel mixing is far too complex, and the materials required are far too difficult to work with. You have to print it. This brings us to the AE in DART AE, additive engineering. Hypersonics Launch Systems completely abandoned the traditional methods of aerospace manufacturing and embraced the bleeding edge of 3D printing. They partnered with specialized additive manufacturing firms to print the entire Spartan scramjet engine as a single, unified component. They print it using high-temperature aerospace-grade titanium alloys and advanced ceramic matrix composites, CMCs. The strategic implications of this manufacturing method are absolutely revolutionary. In the traditional defense industry, building a high-performance jet engine takes months, sometimes years of supply chain coordination, precision machining, and assembly. If a single subcontractor fails to deliver a specialized bolt, the entire production line grinds to a halt. With the 3D printed Spartan engine, the process is consolidated. The raw titanium powder is loaded into the additive manufacturing machine, the lasers fuse the powder layer by microscopic layer, and a few weeks later, a fully formed, flight-ready hypersonic scramjet engine emerges from the printer. This is the death of the boutique prototype. Because the engine has no moving parts and is manufactured via 3D printing, it is inherently scalable. If the Royal Australian Air Force or the United States military suddenly requires 500 hypersonic missiles to repel a Chinese naval blockade, they do not have to wait 5 years for a traditional factory to spool up. They simply spin up more 3D printers. Australia has successfully engineered a hypersonic apex predator that is not only faster and more maneuverable than the competition, but critically, it is designed from the ground up for ruthless, rapid, wartime mass production. From research to the Hypersonic Attack Cruise Missile, HACM. Having the world's most advanced 3D printed scramjet engine is a massive industrial triumph. But an engine is not a weapon until it is integrated into a kill chain. The Australian government and the Pentagon recognized that the DART AE technology and the sovereign testing infrastructure at Woomera were the keys to unlocking the ultimate tactical strike weapon. This realization birthed the Southern Cross Integrated Flight Research Experiment, known as SCI-FIRE. SCI-FIRE was a bilateral initiative between the U.S. Air Force and the Royal Australian Air Force to jointly design, test, and manufacture an air-breathing hypersonic cruise missile. The goal was to take the scramjet propulsion technology perfected in the Australian laboratories and weaponize it. The success of the SCI-FIRE program was so profound and immediate that it directly evolved into one of the most highly prioritized, heavily funded acquisition programs in the United States Department of Defense, the Hypersonic Attack Cruise Missile, HACM. The HACM is the kinetic, war-fighting manifestation of the Australian-American Hypersonic Partnership. Unlike the massive, silo-launched ballistic missiles or the heavy, rocket-boosted glide vehicles, the HACM is a tactical, air-launched weapon. It uses a small solid rocket booster to accelerate to supersonic speeds, at which point the air-breathing Scramjet engine takes over, propelling the missile to Mach 5 and beyond. Because it breathes atmospheric oxygen and utilizes advanced aerodynamic shaping, the HACM is relatively small. It is small enough to be carried by tactical fighter jets. This changes the entire strategic geometry of the Indo-Pacific. The F/A-18 and F-35 arsenal. If you want to understand why Beijing's strategic planners are terrified of the HACM program, you must look at the platforms that will carry it. The Royal Australian Air Force operates a massive, highly capable fleet of F divided by a -18 F Super Hornets. In a traditional conflict, the Super Hornet is a formidable strike fighter, but it is a fourth-generation non-stealth aircraft. In the heavily contested airspace of the South China Sea, saturated with Chinese HQ-9 surface-to-air missiles, a Super Hornet is highly vulnerable. But by strapping the hypersonic HACM to the pylons of the Super Hornet, you instantly transform a legacy fourth-generation fighter into a strategic, long-range assassin. The RAAF Super Hornet no longer needs to fly into the teeth of the enemy air defense network to deliver its payload. Operating under the shoot and scoot air doctrine, a squadron of Australian Super Hornets can launch from RAF base Tyndall in the Northern Territory, fly out over the Philippine Sea, and remain hundreds of miles away from the Chinese fleet, safely outside the engagement envelope of Chinese carrier-based fighters and destroyer-launched missiles. From that safe, standoff distance, the Super Hornets release a barrage of HACMs. The missiles accelerate to hypersonic velocities, screaming toward the target at over 3,800 miles per hour. Because they are air-breathing cruise missiles, they do not follow a predictable parabolic ballistic arc into space. They fly low, maneuvering aggressively within the atmosphere, riding the very edge of the radar horizon. By the time the Chinese Type 055 cruiser detects the incoming threat, the missiles are mere seconds away from impact. The kinetic energy alone of a projectile moving at Mach 5 is enough to break the keel of a warship, even before the high-explosive warhead detonates. Furthermore, this lethal capability is deeply integrated with the RAF's fleet of fifth-generation F-35A Lightning II stealth fighters. The F-35 acts as the invisible, omniscient forward observer. Operating deep inside contested airspace, utilizing its unmatched sensor fusion and passive tracking capabilities, an Australian F-35 can identify the exact coordinates of a high-value Chinese target, such as a mobile ballistic missile launcher or an aircraft carrier. The F-35 pilot does not need to drop a bomb. The jet simply beams the targeting data securely across the Multifunction Advanced Data Link, MADL, back to the Super Hornets loitering safely over the horizon. The Super Hornets launched the HACM swarm, guiding them to the kill based entirely on the stealth fighter's data. This SCI-FIRE kill web turns the entire Royal Australian Air Force into a distributed, untouchable hypersonic artillery battery. The mathematics of saturation. The technology behind the Scramjet and the tactical brilliance of the air-launched kill chain are undeniable. But in the ruthless, unvarnished reality of great power competition, a war against an industrialized superpower like China will not be won by the elegance of your prototypes. It will be won by the depth of your magazines. This brings us to the core reason why Australia has shifted violently toward the mass production of hypersonics. It is the brutal economics of swarm warfare. The Chinese People's Liberation Army Navy plan is not a collection of defenseless targets. It is the largest surface fleet on Earth, and it is heavily defended. A modern Chinese task group is protected by layers of overlapping radar, electronic warfare jamming, and hundreds of vertical launch cells packed with interceptor missiles. If the Western Alliance launches 2 or 3 exquisite $100 million hypersonic weapons at a Chinese fleet, the mathematical probability of success is dangerously low. The Chinese destroyers will ripple-fire dozens of interceptors, filling the sky with shrapnel and electronic noise, prioritizing the survival of their aircraft carriers at all costs. You cannot defeat a heavily defended naval armada with a sniper rifle. You need a shotgun. To penetrate the Aegis-equivalent air defense networks of the plan, you must achieve magazine depletion. You must force the enemy ships to shoot all of their defensive missiles at the first wave of incoming threats. Once their vertical launch cells are empty, they are completely defenseless, and the second wave of the swarm strikes home. To execute this strategy, you must launch an overwhelming synchronized volley of dozens, perhaps hundreds, of hypersonic and supersonic cruise missiles simultaneously. This is the mathematics of saturation. And it dictates a very simple, inescapable industrial truth. The West needs thousands of hypersonic missiles. You cannot stockpile an arsenal of thousands of missiles if each missile requires a year of bespoke machining in an American laboratory. The production lines must run hot. The missiles must be relatively affordable, highly reliable, and capable of being pumped out of a factory at a wartime cadence. The 3D printed, zero moving parts architecture of the Australian Spartan Scramjet engine is the exact technological solution to this massive logistical problem. Australia is standardizing the components, simplifying the engineering, and bringing the unit cost of hypersonic strike down from the realm of the exotic into the realm of the expendable. The titanium fortress of Brisbane. But true mass production requires more than just 3D printers. It requires a sovereign, unbreakable supply chain. You cannot mass-produce hypersonic weapons if you rely on the adversary to supply your raw materials. In the aerospace industry, the ultimate currency is aerospace-grade titanium. It is light, it is incredibly strong, and it can survive the extreme thermal dynamics of Mach 5 flight. For decades, the global supply chain for processed titanium sponge and advanced aerospace alloys was heavily dominated by China and Russia. The free world realized that fighting a war utilizing weapons built from Russian and Chinese titanium was a strategic suicide pact. Australia, possessing some of the largest reserves of critical minerals, rutile and ilmenite, the precursors to titanium, on the planet, stepped into the void. The Australian government and the Defence Industrial Base have launched a massive initiative to secure the entire supply chain, from the mine to the missile. They are rapidly scaling up domestic processing facilities to refine raw Australian or into the aerospace-grade titanium powder required by the 3D printers. This sovereign supply chain is physically manifesting in facilities like the Brisbane Hypersonic Research Precinct. Queensland is rapidly becoming the Silicon Valley of hypersonics. The concentration of aerospace companies, advanced manufacturing firms, and dedicated research universities in Brisbane is creating a critical mass of human capital and industrial capability. The West is building a completely sovereign, closed-loop manufacturing ecosystem entirely within the Anglosphere. The titanium is mined in the Australian outback. It is refined in Australian processing plants. It is 3D printed into scramjet engines in Brisbane laboratories. It is tested in the massive, restricted airspace of Woomera. And it is ultimately deployed on the wings of Allied fighter jets across the Indo-Pacific. This is the ultimate Pacific arsenal. It is an industrial fortress that Beijing cannot blockade, cannot sanction, and cannot outproduce. The era of the hypersonic laboratory is officially dead. For years, authoritarian regimes used the threat of hypersonic glide vehicles as a psychological weapon, attempting to convince the democracies of the world that resistance was futile and that the American security umbrella was fundamentally obsolete. They banked on the assumption that the West was too slow, too bureaucratic, and too deindustrialized to respond in kind. The sudden, aggressive awakening of the Australian Defence Industrial Base proves that assumption to be a catastrophic miscalculation. Through the AUKUS Pillar II agreement and the massive investments in domestic aerospace engineering, Australia has transformed itself from a middle power dependent on foreign supply chains into the indispensable hypersonic workshop of the free world. The 3D printed scramjets roaring over the Woomera test range are not just scientific experiments. They are the physical, kinetic proof that the Anglosphere is aggressively scaling its most lethal strike capabilities. We are moving past the prototype. We are embracing the brutal economics of swarm warfare, ensuring that if the order is ever given, the Royal Australian Air Force and its allies will possess the magazine depth required to shatter the defenses of any adversary. Australia is no longer just buying weapons to defend its coastline. It is printing the apex predators that will lock down the Indo-Pacific, proving that the free world still possesses the industrial might to out-innovate, outbuild, and outgun the enemies of democracy. Thanks for watching Doctrine of War. Do you believe that relying on 3D printed, mass-produced hypersonic swarms is the ultimate strategy to deter China? Or should the West continue to invest in massive, exquisite platforms like stealth bombers? Let us know your tactical assessment in the comments below. Stay sharp, stay relentless, and we'll see you in the next one.